In the realm of military innovation, Japan has once again taken the lead by unveiling its latest marvel, the Railgun. This cutting-edge technology represents a quantum leap forward in the realm of defense, boasting unparalleled power, efficiency, and modern warfare capabilities. But what exactly is this innovation, and what will Japan do with it? Stay tuned to find out. On October 17th, a Japanese organization shared a brief clip on Twitter, showcasing an unconventional weapon firing a shot from various angles, resembling something out of a Lego set. This marked the inaugural firing test of a ship-mounted railgun, a groundbreaking achievement in military technology. However, before we get into that, let's talk about railguns and what they do. Once considered the dream of science fiction, nations have dedicated decades to transforming railguns from fantasy into reality. The specific term for the weapon tested by the Japanese is a developmental electromagnetic railgun. Despite the extensive time and financial investment poured into their development, railguns are fundamentally straightforward devices, consisting of three main components. Firstly, there's the power supply, which is critical as railguns demand immense amounts of electricity. Even a moderately sized railgun can necessitate a staggering electrical service of 1 million amps, dwarfing the typical 100 amps required for an average household. In simpler terms, a railgun can consume as much electrical current as 10,000 homes combined, with larger versions drawing even more. The second component comprises the rails themselves, typically made from two parallel conductive metal lengths, often copper due to its high conductivity. The rail length varies depending on the railgun size, ranging from a modest 4 feet to an imposing 30 feet. Lastly, the armature, which is the part responsible for the actual projectile firing, completes the railgun. The armature can range from basic conductive metal pieces to more complex configurations involving plasma, where a thin metal foil, when vaporized by the gun's activation, becomes the conduit for launching the projectile. While this may seem complex, at its core, a railgun operates as a large-scale magnetic launcher. When the electric current flows through the rails, it creates a magnetic field that propels the projectile away from the power supply at remarkable speeds, thanks to the Lorentz force. Once the projectile exits the railgun, the circuit breaks, halting the current flow and deactivating the magnetic field. Essentially, a railgun is like a traditional firearm, but utilizes electromagnetism instead of chemical propellants like gunpowder. This shift in propulsion mechanisms represents a significant departure from conventional weaponry, signaling a new era where the power of electricity is harnessed to propel projectiles with unparalleled speed and force. What sets railguns apart is their remarkable ability to launch projectiles at incredible speeds, reaching Mach 5 or even higher. To put this into perspective, Mach 5 signifies a velocity 5 times faster than the speed of sound, which translates to over 6,000 kilometers per hour. For comparison, a typical bullet fired from a gun travels at around 3,000 kilometers per hour, while even the fastest supersonic cruise missile, the BrahMos ALCM-FAS, operates at similar speeds. The Lockheed SR-71 Blackbird, renowned as the fastest jet aircraft globally, can exceed speeds of 3,500 kilometers per hour. The only weapons surpassing the railgun in velocity are ultra-modern hypersonic missiles, making the railgun an exceptionally fast contender in the arsenal. This remarkable velocity affords the railgun distinct advantages. Firstly, it grants an extended range compared to conventional weaponry. Secondly, the immense speed translates into significant kinetic energy upon impact, resulting in substantial destruction without the need for large quantities of explosives. This aspect is particularly advantageous economically, as traditional weapons rely on costly explosives to achieve similar destructive effects. In 2014, during the U.S. Navy's railgun tests, the chief engineer expressed hopes that the railgun would enable the Navy to counter various threats cost-effectively, while reducing the need for high explosive weapons, thus enhancing ship and crew safety. The reliance on explosives in conventional weaponry poses significant risks, both in terms of cost and safety. Carrying explosives on board ships not only incurs expenses but also increases the potential for accidents and catastrophic events. Any incident, from enemy attacks to accidental fires, could result in extensive damage and loss of life. However, despite the apparent advantages of railguns, widespread adoption has been slow, prompting skepticism regarding their practicality. You might question whether all of this appears overly optimistic. A futuristic armament that converts chunks of metal into lethal projectiles. Well, you're right to be suspicious. There are many reasons why it's taken so much work to get railguns working. The first challenge is straightforward: power. Achieving velocities of Mach 5 and beyond is an immense task that demands staggeringly large amounts of power. Consider that even moderately sized railguns can draw in excess of 1 million amps of electrical current. However, acquiring such power presents a dilemma, especially at sea. Unlike on land where constructing a power generator is feasible, space and weight limitations aboard ships complicate matters. Moreover, the larger and heavier a ship, the more power it requires merely for propulsion, making it impractical to draw power from the ship's propulsion system. Consequently, a separate power source becomes necessary. While next-generation ships offer the flexibility to divert power temporarily from the propulsion system to fire a railgun, challenges persist. The significant power and force generated also result in heat, necessitating robust cooling systems to prevent overheating. Additionally, despite their seemingly simple appearance, railguns are intricate pieces of modern military technology. The equipment involved is not only heavy, but must also be securely mounted to withstand the rigors of rough seas without becoming dislodged. So does this mean that railguns are impossible to make? The specific intentions of Japan regarding the use of this weapon remain undisclosed, shrouded in mystery. Nevertheless, informed speculation can be made based on certain indicators. For instance, several years ago, Japan introduced a couple of new destroyer types, alongside suggestions that they could potentially be outfitted with railguns, accompanied by artists' renderings illustrating such possibilities. The versatility of railguns enables them to engage a wide array of targets, including aircraft, ships, missiles, and more. Notably, one of the most appealing aspects of railguns is their potential effectiveness in intercepting incoming missiles, including the latest hypersonic ballistic missiles under development by Russia and China. The rationale behind Japan's pursuit of operational railguns can be understood within the context of its security concerns. Despite constitutional restrictions on offensive military actions, Japan is fully authorized to act in self-defense. Perceiving itself as surrounded by significant threats, Japan allocates substantial resources to its military, known as the Japan Self-Defense Forces, boasting one of the world's highest defense budgets. On one front, Japan contends with North Korea, a volatile neighbor notorious for its missile provocations and ongoing missile advancements. On another front, there's China, the world's second most powerful nation, which harbors historical grievances against Japan and asserts territorial claims in the contentious South China Sea. Well, that's about it for today's video. What do you think of Japan's railgun? What do you think they will do with it? Let us know in the comments below. We would love to hear from you. If you liked today's content, do give us a like and subscribe to the channel. Thank you so much for watching, and we'll see you on the next one.